Dear audience, my name is Vivian Ogechiwadir. I am the chapter secretary and will be your host for today's talk. It is with great pleasure that the UMass Amherst Student Chapter of Informs and its faculty advisor, Professor Anna Nagoni, receive you for the seminar of Dr. Robert Lougee. Dr. Lougee is a member of the Board on Agriculture and Natural Resources at the National Academy of Sciences, Engineering and Medicine, and the former Global Research Industry Lead for Consumer at IBM Research. She is known for her service to the Informs community and spearheading new initiatives that benefit industry and academia. Dr. Lougee is a founder of CoinOR, the open source initiative for operations research software, the Informs Professional Colloquium, now the Early Career Practitioner Network, and the Signature Crop Challenge in Analytics. So, could you please mute your mic? Thank you. One more relevant remark. Dr. Robin was recently elected Vice President of the Practice of Informs, and for that, we do congratulate her. Thank you for accepting our invitation and for sharing your knowledge with us. We're indeed honored by your presence. We will now invite Dr. Nagoni to give some welcome remarks.
Greetings, everyone. It's such an honor to have Dr. Robin Lougee joining us. This is the first actually event that we're hosting of the new academic year. I've known Dr. Lougee for quite a few years, and I've always, marveled at her achievements and her ability to do fantastic research. Also, she's so active in terms of the Informs Practice group. Many activities. So welcome everyone. Thank you for taking part. And I think this is going to be an extraordinary presentation. So thank you.
So I'm going to share my screen now, if I can. Okay, I am honored to be here today. Thank you, Anna and Vivian and Paula, for asking me to present to the UMass Amherst Student Chapter of Informs. I'm especially honored because if I understand correctly, your Thanksgiving break is starting. So I really appreciate the opportunity to talk to you as you take a break from the semester. The presentation I want to share with you today involves some work my team did at IBM Research, and it relies heavily on a presentation with my client. So I hope one of the things that I can give you is also the voice of the client about the kind of work and impact that our tools and technology and operations research can have on a company. Just a big thank you to this incredible organization. If any of you aren't members, I encourage you to join. This is the second time I've had the pleasure of presenting to the chapter. I've looked back in my notes, and the last time I was up there was actually in person in 2006. So it's a pleasure. I wish we were all in person so I could see you rather than just looking at my screen, but hopefully it won't be too long till we're able to do that again. So what I want to tell you about today is a multi-year research collaboration between IBM Research and a company called McCormick. And I'm going to organize my talk into three parts. The first part, I want to tell you about the problem, and this involves product development challenge. So you're very familiar about products because you buy them all the time as consumers. So for example, in this picture here, taken from a local grocery store, you are, as a consumer walking down the aisle, have a variety of products to choose from. Here it's potato chips and many different flavors. So I don't know if you've ever stopped to think, who comes up with these flavors? And how do they create them? Or especially when you see new and improved, why did they do that? Or how did they do it? And is it actually better? Well, that's the problem we're going to dig into today. The second part of the talk is going to talk about computational creativity. So what is it and why would we care to even think about it? And the third part is I'm going to tell you about a system that uses computational creativity to solve the product development challenge. And this is actually a system that's in production. Unfortunately, it is a proprietary system. So I'm not able to show you the user interface or walk you through examples or tell you about all the deep technology underneath. But my goal for the talk is to at least give you a sense of how the system works and maybe some of the interesting challenge involved. So let's get started. So McCormick & Company is a very old company. It was founded in 1989, and it's the largest flavor company in the world. So you may know these from shopping in your local grocery store, some of their products, or recognize the McCormick logo. They have 35 brands, over 17,000 products sold in 160 countries, and that requires them sourcing over 14,000 raw materials from over 85 countries around the world. So it's a big, complex system to produce all this for consumers. I grew up in the College Park area in Maryland. And so Old Bay seasoning is, was always on the table. So I hope you recognize maybe some of these, like Frank Red Hot sauce. These are consumer products that you may know, but that's only one division of McCormick. You are consumers, but a consumer product company like McCormick also can sell to other companies. So not just a consumer, you, the end user of the material, but to other companies like restaurants and fast food services or other product companies like in your flavored cereals or like the potato chips I showed you. So about 60% of McCormick's business is in consumer products. About 40% is in the division that they call flavor solutions. Now, McCormick, I said, was the largest flavor company in the world. They say in the United States that you can't go a day, if you're a normal eater, without eating something that directly or indirectly has McCormick's products in it. They serve the top 10 fast food restaurants, the top 10 consumer product food groups. So it's very big. The group that supports the development of all those products, both for the consumer market and for the flavor solutions market, is an R&D organization. And it's a global team of 500 culinary scientists from around the world. And they are staged in over 20 technical innovation centers in 14 countries. And Morningstar said that the McCormick Research Labs have become, the best in the industry in their opinion. And, I've been very impressed with working with them throughout the years, because this is a very unusual project, as I hope I'll get to tell you in a few minutes. So we all eat food. Most of us cook food. We go to restaurants. So my challenge here to tell you about this problem is to have you think not about yourself as a chef or as a home cook, but a slightly different world. And that's the product developer's world, or the world from McCormick's point of view. So I want to challenge you to just think about that for a second, as if you yourselves were from McCormick. So what's happening in the product development landscape for them? So I'm going to talk about a few different areas. One has to do with the changing consumer. So the younger generation, which is many of you in this audience, are very different from older generations in a variety of ways. And you're demanding different things from your products. Now, I'll give you an example. When I grew up, we had strawberries once a season. That's the only time they were available in the supermarket. But nowadays, with the globalization of the food system, we have strawberries year round. You know, they're flown in. So this has affected the globalization, and the way we've integrated with other companies has made ethnic flavors in the US and around the world more in demand, and not just the more different flavors, but also looking for things like natural, sustainable. So different types of products than existed before. So we have a changing consumer. That's a consumer is the person who actually buys and uses the product. McCormick also has the business customers I talked about. So their customers are the other businesses, not just grocery stores where they sell their own products, but the Flavor Solutions division has their corporate customers, and they're facing competition. So they want to reformulate products in order to manage costs because of government regulations around the world. You know, for example, you may know that Europe has a different requirements, a slightly higher bar for some of the ingredients that go in the product in the US. So for example, some of the dyes, like yellow food dyes number 5 and 6 and red dye 40 can appear in products in the US without any disclaimers. But if you were to buy the same product in Europe, the company would be forced to have a disclaimer on the package that says, this may have an adverse effect on activity and attention in children. So if a customer doesn't want to have that perhaps negative statement on their product package, they would reformulate the product. And this would be a challenge for the food product developer to how to make the product without certain ingredients, for example. Product developers are trained using an apprenticeship, and it takes a long time to develop a great product developer, even after they've graduated from school and have a degree. It still takes 5 to 10 or more years for them to learn the trade by apprenticing to a more senior. And that's a long time if you're thinking about yourself as a company like McCormick that needs a pool of these talented product development specialists. And moreover, if that person leaves for another company or retires, a lot of their know-how and knowledge leaves with them. So that's a challenge. There's actually a talent war for these people. Another challenge is materials. The sheer number of materials that a human being has to know about as a product developer. So I'll give you an example. In my kitchen, I have 2 types of garlic. It's either a fresh garlic or it's a powdered garlic. And the fresh garlic, there's just one in my store. I think it's a California garlic. A McCormick product developer would have dozens and dozens and dozens of type of garlics to choose from. So they have to know about the qualities of each one of those types of garlics. For the example, they might use an Asian garlic. They might use a Chinese garlic. They might use a California red garlic. Just like a Vidalia onion has a special flavor because of the soil it's grown in, and so they can label it Vidalia. Different kinds of onions have different flavors, much like wines, which you may be familiar with, like a Burgundy wine, right? Comes from the region of Burgundy because of the soil. So there's a large number of materials to choose from, and then the materials are available in many different forms. So to continue on our garlic example, you might have a very fine powdered garlic, and this would have different attributes in terms of the taste experience of the users because a fine powder coats the tongue, and so you taste it very quickly. But you may be making something like a rub for a barbecue, and so you want the user, who typically may be a male and may want a manly looking spice, to see big chips of garlics in there. So they have to take a lot of consideration for both the product they're developing, who their user is, and how it performs in their product. And the number of choices can be overwhelming for any human. The fifth aspect has to do with the stage gate process. So product development in the food and flavor industry follows a stage gate process, sometimes called the phase gate process. which is a waterfall process. You do an iteration, and at the end of that iteration, there is a gate, which is a decision point, which you decide whether or not to continue. It is very time consuming and very slow. And lastly are the new regulations. And we touched upon this a little bit and we spoke about the challenges of the customer, but they're constantly changing. And so McCormick needs to keep abreast of those and take them into consideration. So the question is, from McCormick's point of view, it's not just them that are facing these challenges, it's everyone in their business. So how can McCormick take these challenges and turn them into competitive advantages for their companies? So that's the problem and the background we're thinking about. The chief science officer of McCormick has this amazing vision of how he wants the future of their company to be. His vision is to take this slow stage gate process and somehow accelerate it. Accelerate it so the rate of innovation is 300% better. You know, I mentioned that every one of the product developers goes through some sort of apprenticeship process. So all the product developers are not at the same skill level. So he'd like to have one global team. And how can he elevate the capabilities of every product developer, regardless of their seniority, so that they're all at the level of the best? Now, the products that they're developing, you may have seen in the abstract, you know, 80% of new products tend to fold. The ones that stay are called icons. Examples of icons would be products that have been on the market for generations that your mom and your grandma may know, like an Oreo cookie or a Philadelphia cream cheese. But how does a product developer knowingly create an icon? Right now, it's very much a trial and error process. And so finding an icon is like a needle in a haystack. So we want to be able to develop some kind of capabilities to help product developers more knowingly create products that become icons and last, because the development process takes a long time, takes resources, and so it's costly. So simultaneously, we're looking to help product developers be better, be faster, and more cost effective. And this is a big challenge. And yet another aspect of this that I want to mention is the change in consumers towards health and wellness. So how can we make better for you products? Because this is attracting consumers. So for example, sodium, sodium is not good for you. And a lot of products use sodium because it's tasty, right? We like sodium. So how can we reformulate products so they use less sodium, but don't have less flavors? That's something a product developer is looking at. So I really briefly described a bit of the product development challenge. So hopefully I've given you a sense of the environment. And so now I'd like to switch over to the second part of the talk and talk about computational creativity. And I'm going to start with talking about artificial intelligence, because it is such a buzzword today, and so many companies are exploring how can they use artificial intelligence to improve their products and services and operations. So IBM Research, where I worked and where this collaboration was done, is a long history of working in artificial intelligence. And a lot of the ways we advanced the state of the art were taking on challenges that were games, like creating a system that could beat the Garry Kasparov, the reigning world chess champion at the time, or creating a system like the Watson system, and taking on the challenge of trying to beat the best humans in the world in Jeopardy. Likewise, Google has taken on this challenge of trying to create systems that can be better than humans in games like the game Go, and succeeded very well. So all this work is around thinking and intelligence. So for example, in Watson, in the Jeopardy game, there's an answer and it's either right or wrong, right? You think. that's not exactly what product developers are doing, right? It's not a question of getting a right answer. They're solving a slightly different problem. The problem they're thinking about is more around doing things different or creativity. So I'd like to, given what you know about artificial intelligence, ask you to think about, what does it mean to be creative? Are you more creative than your parents? What is it? How do you define creativity? How do you measure it? One definition I like is by Bowden. And Bowden said creativity is the ability to come up with something that is both surprising, new, and valuable. And there's a lot of different definitions of creativity, but they usually have two aspects to them. One is the surprising aspect, and one is the valuable or useful aspect. And like beauty, what surprising is to me may be different than surprising to you. What is useful to me may be different than useful to you. So it's still very, very subjective. Just defining creativity is an ongoing challenge. So when we talk about computational creativity, we're talking about creating a system that mimics human creativity. Colton and Wiggins define computational creativity as the philosophy, science, and engineering of computer systems, which by taking on particular responsibilities, exhibit behaviors that unbiased observers would deem to be creative. Now that's a very nice definition. And you might notice that they depended on unbiased observers. Different definitions of computational creativity may not have that, and may say, observers who are skilled in the art. So there's a lot of different ways to define it. And this challenge of computational creativity has been exciting people for many years. In fact, there's an association for computational creativity, which has been going on and having organizing events for more than 20 years. And computational creativity is the multidisciplinary endeavor that's located at the intersection of fields, and particularly artificial intelligence, which we talked about briefly, cognitive psychology, philosophy, and the arts. When we talk about creativity, and you were thinking about it a minute ago, you probably thought of being creative in some artistic way, like a painting or drawing, or maybe music or dance. People have been exploring the challenge of computational creativity in all of those, and even in jokes. Can we take a body of literature and create a system that can make jokes? So since this is the beginning of a holiday break and a Friday, I thought I would give you a quick example, and it involves food since that's the topic of what we're talking about. So question, what do you call a murderer with fiber? And there's a little clue in the picture next to it. The answer is a serial killer. Aha. So this is a pun created by a system called JAPE, the Joke Analysis Production Engine by Ritchie and Binstead in 1994. So a lot of different systems, and you might ask, why would we spend time working on a pun generation? People think that creativity is the epitome of intelligence in some regards. So by working on creativity, we're actually advancing artificial intelligence. Other people think it's a test bed for different AI techniques. The intellectual challenge alone, but in our case, computational creativity is also because of the application that we're talking about. Well, I'd mentioned that IBM Research had this history of working in AI with these grand challenges. So after the Watson system was created and debuted on national television, winning at Jeopardy, we were thinking about what should be the next big grand challenge. And a team thought, okay, how about if we can build a system that wins at Iron Chef, which is a cooking TV show. This was very fun. You know, you're given a bunch of ingredients and you have to make a dish. And they quickly decided that we didn't have the scope or the funding to do a lot of robotics, but the really key to that work is the recipe. So they started a project in a group in computational creativity, and they partnered with the Institute of Culinary Education to focus on the challenges that a human chef has. And this work was very widely publicized. They had a food truck at the South by Southwest conference. They did a project with Bon Appetit Online. They even published their own cookbook. So one day, the chief scientist of McCormick, Hamed Faridi, was driving. Actually, it was Christmas Day, and he was driving on his car, and he was listening to All Things Considered, and he heard a 3-minute segment that was on computational creativity, where one of the people speaking was a scientist from IBM Research. And he got so excited, he tells the story of how he had to literally pull the car over to the side and stop. And he claims that it was a light bulb moment. You know, hearing Lav Varshni, the scientist involved, talk about using artificial intelligence and computational creativity around food fundamentally changed his vision for how McCormick would conduct product development going forward. So what he was starting to think about was, how could he use this emerging technology at McCormick to address all those challenges that I had mentioned to you earlier? You know, he was wondering about, the ability to develop a system that could create product formulas, and one that, like the human product developers, could get better over time. You know, one thing about this space is that a computer can't taste and a computer can't smell. So tasting food, eating food is a very, it's an experience. So how could you create an AI system that could perceive this taste experience of humans? You know, if you think about it, when we've done work in artificial intelligence around, for example, it's dependent on our ability to digitalize the input. So a picture has been digitalized into a grid, a matrix, where there's a RBG, red, blue, green, number. So we've digitalized the input so a computer can reason about it. How could we do that, or could we do that with food? He's also curious about, how the humans would react to the systems. This wouldn't be a project where we could replace the humans. This would be a co-creative project. Would that be possible? And frankly, would these very talented scientists in his research labs embrace AI, or would they see the threat? So, all these were really running through his mind. And he had brought in a lot of independent consultants to talk about this problem with him, and they said it could not be done. He tells stories about talking with other people in his industries, and literally was laughed at. So when he heard this interview with and All Things Considered, he was really excited and reached out to IBM Research, and he declares it to be a match made in heaven in his perspective. McCormick is very unusual in that they have over 40 years of product development data. That's 40 years of McCormick saving formulas, and so that's ingredients and the relative amounts and all the information about them for 40 years. That's very unusual. So they brought lots of data, and IBM brought talent in computational creativity, computing, operations research, data science. And now let me tell you now a little bit about how the project proceeded from there. Because one way you might have thought about the story is, oh, you've already done the Chef Watson work. A new company comes in and you just continue along your merry way. But that's not how it went. When we started to have the conversations with McCormick, we found out that the Chef-Watson system was not well designed for the problems of a product developer. So remember, Chef-Watson was designed for a chef. Now, a chef, you as a home cook, and a product developer at McCormick all are dealing with recipes and ingredients, but the goals are very, very different. A chef may be able to use an ingredient that's very expensive, like a rare balsamic vinegar. A product developer couldn't do that at all. So the number of ingredients, the range of ingredients, the way the products are consumed, shelf life for a product developer would be important. You know, a chef does consider shelf life, but it's very quick, right? He just serves it to you at the restaurant and you eat it. So they're the same, but they're also very different. And there's a couple of things about the Chef-Watson project, the way it was taken on. In the area of computational creativity, there's many different types of creativity, but one of them is called combinatorial creativity. And this may be what you thought of when you were thinking about your own creative process. So often when we're trying to be creative, we generate a lot of ideas, right? Brainstorm. And then afterwards, we figure out which ones are good. So this is a generate and evaluate approach. It's very easy to do the generation. I mean, think of a little kid, you know, with crayons and drawing. They can generate a lot of pictures, but how many of them would you really consider high quality, right? Evaluation. So in computational creativity, the generation step is easy, but the evaluation is very hard. So Chef-Watson had used a notion of Bayesian surprise, which for the purpose of this lecture, let me just say essentially, we measure surprise by looking at two probability distributions, the one before, the prior, and the one after, posterior. And essentially, we're looking at the difference. And if that difference is large, well, we say the change was very surprising. If not, we say it wasn't surprising. So the other thing that Chef-Watson used was something called the flavor pairing hypothesis. And this says that if two ingredients share the same chemical compound, they taste good together. So for example, chocolate and leeks. You may not think of that as being put together, but they share the same chemical compounds. And in fact, you can buy chocolate leek cake and you'll notice that the leeks, because they share chemical compounds, actually bring out a richness in the chocolates. A challenge with this is that different cultures don't necessarily like the same combinations. So for reasons of these and others, we weren't able to build on that Watson system. And I think this is an interesting point in terms of being an operations research scientist or a scientist in general doing applications with industry, is that that the underlying assumptions sometimes don't hold. And so you have to build on your experience, but not necessarily on the technology. So the way product developers tend to think about this space is that they think about exploring the flavor space. So working with McCormick, we came up with a different approach to the problem. And so a product developer, it's very natural for them to think of the creamy space or the sweet heat space or even a floral space or a fruity space. The problem is with this is that no one has defined what these spaces are, let alone come up with some sort of IEEE standard. So our challenge was to figure out, if we wanted to think about exploring the flavor space, about how to encapsulate it computationally so that a system could reason about it. Just like I mentioned with computer vision, how we take a picture and we've digitalized it. How do we digitalize flavor? And this is an unsolved problem. And our team took one approach. And I think this is still a very, very interesting and exciting problem area if anybody's interested in it. So the approach we took depends on the notion of distance. We're mathematicians and computer scientists. We say space, we're thinking about distances. So could we, or could anybody define the notion of distance in flavor space? what's the distance between a strawberry and vanilla? And how does that compare with a blueberry and a garlic? And then could we use that notion of distance for exploration and solving some of the challenges that I described earlier with the product developers? So let me give you an example of how the user interacts with a system that we built using computational creativity. So a product developer at McCormick starts with a brief, typically. So a brief is, say, in the flavor solution space, a customer comes and they want a smoky hot sauce that doesn't taste of ash. So it's a general description, right? But from that brief, the human would start with a seed formulation. So that would be our starting point. That's given input into the system. So now the product developer would start their iterative process. It's a directed process because they know what they want. They know they want that smoky hot sauce that doesn't taste of ash. And so they're going to iterate by trying things, evaluating them. If they like them, great, they stop. If they don't, they try again. The problem is those iterations rely on human evaluation. That's the gold standard, right? You have tasting panels by which you get feedback and you put that into your considerations of the next go around. So what the system does, it supports that process by using AI to make suggestions, which the product developer can accept or reject. They can use part of, they can use none of, they can take an exception, a suggestion and then modify it, perhaps changing the amounts or the ingredients. So it becomes an interactive system where the AI computational creativity system is using historical data to make recommendations to the users. So after the user has a formula that they like, they actually do physically compound that recipe. If it was a chip for a potato chip, like we were talking about, they would physically put it on the potato chip, and then they would bring in a tasting panel. People would taste it. They have a hedonic scale that they measure things on, which is standard for the food industry. And then they take that feedback and decide whether or not to go forward or to revise it. And so that's how the system works in general. So now let me drill in a little bit to this AI area that the system supports. So like an apprentice, our system is trying to learn from all the master product developers in the past, what worked and what didn't work. So the input into it, the 40 years of data that McCormick has is very rich. It has the materials. Those can be raw materials or they can be manufacturing language subassemblies. They have attributes that depend on the materials. They have the formulas that use. The formulas would be a list of the materials and the relative amounts of the materials. And in addition, it has success evidence. And this is really key because as we said before, it's easy to generate new formulas or new suggestions. The trick is in how to evaluate them. So you want to create something that people like. And this is subjective, but you have data based on things like what products were sold before, how long were they on the market before, what samples were sent to customers before, what recipes were used in the tasting, so that indicates that they were better than others. So we take a wealth of historical data and we have 5 machine learning models that are part of the system. So I'll tell you a little bit about each one of them. So the first one has to do with finding patterns. So substitutes, and you do all this in the time in the kitchen. For example, you use flour instead of cornstarch or vice versa. They're similar, but they're functional substitutes. If you're trying to make a gravy, they do the same thing, but they taste a little bit different. So we have a machine learning model that tries to identify substitutes over the corpus of formulas that McCormick has in the past. And these become building blocks. We also have a machine learning model to find complements. So for example, basil and oregano go good together if you're making a Mediterranean dish. So we try to identify things that tend to go together to be used as building blocks. The third machine model has to do with applications. And this didn't exist initially, but it came to be included because there was as we were developing the system over years with McCormick, there was an instance where the system was asked to develop a Cajun seasoned rice mix. And so that target was put into the system and it came out with lots of great suggestions. And they were for Cajun seasoned salt mixes because the system had not been told that it had to have rice in it, but this was a rice mix. So we quickly learned that we had to give the machine learning model more direction about the application and what that entailed. So the application model was born. Now I mentioned distance. This is sort of a fundamental notion in how we're envisioning computational creativity by exploring a space, in this instance, a flavor space. So we learn mathematically a notion of distance between ingredients, and that distance between ingredients is the key to learning a distance between two formulas. And the formulas, of course, are the output of the system and what the user is looking for. So our notion of distance is based, you can formulate this based on an Earth mover's distance, which you may know is a type of optimal transport problem that's derived from Wasserstein metrics. So in the distance, and in essence, this is the hard part. We're trying to learn this mathematical notion of distance, and I find this to be a very, very exciting problem. So given all that, we still need to know a notion of success. I mentioned success evidence before. So this would be our evaluation criteria from all the possible candidate suggestions that we can generate. So based on these 5 machine learning models, our AI system generates lots of suggestions with balanced proportions and innovations. So that in a nutshell is what's behind the system. Another aspect to it is as focus. So for example, we can generate all these different suggestions and we have the focus area that the user cares about. And we have to be careful because the human user can only evaluate so many suggestions. So it depends on what they're looking for, and the system has many different modes of operating. But in essence, we also solve a type of covering problem because if a suggestion is too close to an existing formula, the user may not want to see that. It's too close. They may be interested in only knowing about things that are in a white space. And this, of course, depends on what the intention of the user is, which we don't know, but we try to cover the space so that we can give them a range and then present only the best ones to them. Now, I mentioned this idea of distance, and that's how we define creativity. Sometimes a user is looking to be wildly creative, no hold bars, let me find some exotic combination of ingredients. But more often, the users are also interested in perhaps optimizing. If you remember, there used to be Coca-Cola at one point was trying to make its flavor even better, and they generated the new Coke, right? People got really upset because they liked old Coke. So this is something that product developers have to do for the reasons I mentioned before, involving cost, availability of products, shifting, changing landscape as reformulate products that are already known. And in many of those cases, they're just trying to make things better. So for example, if you want to make a product sweet without adding sugar, you can add types of vanilla. If you want to make a cheese product, like your nachos or something, if you want to make something cheesier, how do you do that without adding more cheese? Because that's expensive. But you can add a little garlic, and that actually enhances your perception. So the product developers have different degrees of creativity depending on what the brief is or their goal is working. And so the system uses the notion of distance, for how far away it's looking, and that supports these multiple levels of creativity. So let me just summarize again in a slightly different view, is that given all the input that we're getting from McCormick, lots of type of data, whether it's the consumer screenings or the the recipe, the cost data, the property ingredients. We use all that historical data and essentially have 5 machine models that are at the core of the system. The substitute and complements are actually types of design patterns that we're finding. I mentioned formula distance, the application, what kind of product we're trying to make, and we generate new formulas for the product developer to work with. And they're not taking this as a black box and just using it. They're actually working with the system. So it's co-creation. It goes back and forth between the human and the user until they come up with something they like. And so this is a win for McCormick, because this interaction allows the human product developers to take advantage of knowledge that they may not have had at their fingertips, and to do it faster than they could have before. And we're very excited that McCormick has found this technology to be valuable. And one thing that's very different about this project than any other project I've worked on is that usually as data scientists or working in AI machine learning, one of the values we bring is that we get to know the data better than the client does themselves. Well, in this case, the data we were working with was literally the secret sauce. And that data is so, the intellectual property is so valuable. If McCormick is working with companies, it can't be shared, we can't see it. So the data was encoded. So we had to work with this data, not being able to fully see the data we were working on. So it made for some very interesting challenges. And we also had to rely on the human deciding whether or not to accept our recommendation. So for example, in one case, a user was using the system for a Chipotle pumpkin pie, was doing it for pumpkin pie seasoning, and Chipotle pumpkin pie came out, and the user said, "Oh, that sounds terrible." And if your user doesn't like the suggestion, they're not going to use it, and the system doesn't have value. So you have to be creating solutions that the user is actually open to using. And it was funny, another product developer saw the same suggestion and thought that was terrific. And it turns out Chipotle pumpkin pie is actually that happens. There are recipes for it. You may have even tried it yourself. Another example about biases between the system and humans just has to do with our unconscious biases. So for example, if you're trying to develop a pizza seasoning, as one product developer was, you're thinking Mediterranean, right? You're thinking basils and oregano. Well, they used the system, and the system recommended cumin. And they thought, that sounds interesting. And actually the cumin did bring out a sort of umami flavoring, a warmth. And that was another success we had. So when McCormick went to launch its new One product family, and if you're not familiar with this, it's a seasoning that goes over protein and vegetables so that you can cook it in one sheet pan or one skillet. They announced to the world that 3 of the, I think it was 12 at the time or 9 products were actually developed with the computational creativity system. And so we were very excited about this, to have such a huge win, to have something that you can find now on Amazon and Walmart, being sold by McCormick that use the system. And moreover, by the end of the year, they're going to roll out the system, not just to the labs that we are working with in our research collaboration, but worldwide. And they think that this is going to help them achieve their target of speeding up innovation by 300%. I feel very fortunate that McCormick and IBM agreed to announce their collaboration. Often when you work in industry, the most exciting problems are too valuable for the company to disclose them to the public and talk about them. But in this case, they agreed, and the response was wide. I mean, people love food, right? Who doesn't like food? So we had a lot of placements about the work in a variety of magazines, including the front page of the Wall Street Journal special section on AI. So from McCormick's perspective, this system is not only helping them, it's helping their whole industry because they believe that this is going to be a new approach that revolutionizes product innovation because there hasn't been a lot of major changes since the stage gate process. So they feel that they are presenting an improved starting point for their developers using collective knowledge thanks to that body of information and using information from the very beginning of the process that they couldn't previously. So very quickly, let me just tell you what McCormick is telling their clients, that they feel like using AI allows them to have a competitive advantage because there's so many things being covered. And I focus mostly on flavor, but also on cost, sustainability, and carbon footprint, drivers of things that are making them reformulate their products. It makes them more agile and attractive to their partners because speed is of essence when you have a company asking for a product. The faster you can do it, the more competitive advantage you have over your clients. And the best talent is often attracted to the state-of-the-art technologies, and they've had instances now where they've been able to hire outstanding people because of their use of AI, which is leading edge in their industry, and of course advance their functional portfolio flavors. They have big visions of being able to mass produce solutions in a customized way for you for personalized flavor. Like if you wanted your own barbecue seasoning for your wedding, right? A special blend, they would love to be able to do that for you. And now with e-commerce, there's an unlimited shelf space in e-commerce, but the challenge has been how to turn around those flavors fast enough. So maybe in your lifetimes, you'll be able to see that. And of course, personalized flavor leads into personalized nutrition. So they're very excited about the potentials. And so they would tell you that the future of flavor has arrived. And so it was an exciting project for me to be involved in. And while I talked a lot about food, the same thing happens in many other products. We also worked with a fragrance company, Simrise, that was a supplier to O Boticario and created the first AI perfume. This was just in time for a Brazilian Valentine's Day. And you can see here on the bottle, and this is a test one, they listed IBM research. Part of the O Boticario's market presence was saying it was AI generated. It turns out people don't have the same reaction to having AI mess through their food. So on the McCormick products, you will not see anything about AI itself. So I'd just like to thank the incredible team that I was able to work with at IBM Research and for the work on this product. It was a lot of fun. And thank you for letting me share it with you today. And in leaving, I just also wanted to put out a quick call. If anybody would like to join us for a networking happy hour, the practice section has a special one today at 5 p.m. Eastern, which is an open office hour. It's going to be completely dedicated to answering any questions students or early career practitioners have of us. So I hope you'll consider joining us. Thank you.
Thank you so much, Dr. Robin Lougee. This was a very exciting presentation. I love food, and it's just it's myself a home cook. So I really enjoyed your talk and thinking about how flavors are made. I had never really thought about how my flavors on the kitchen table are made. So that's really interesting. I'd like to open the floor for questions and any remarks from Dr. Nagurney.
I have actually some comments. Thank you. That was absolutely brilliant. That was like a Renaissance OR talk. It was fantastic. I loved it. I also very much appreciate that you allowed us to record it so we can share it with the world and post it on our YouTube channel. I think you will get zillions of invitations. I hope you don't mind. But it was so interesting. I thoroughly enjoyed. I have a question about McCormick. When I think about McCormick, I think of our pantry and all the spices that we have with McCormick on it. What percentage of their business is spices versus other kinds of products, maybe for other, companies and so on?
That's a great question. I don't know the answer. I do know that their retail, what they sell to consumers like you and me in the grocery store is 60% of their business. So 40% is creating things for other companies. Like when you go to Starbucks and you have some of those fancy caramel, white chocolate, peppermint mocha things, who makes those flavors? Those are companies like McCormick.
Okay, that's really, really interesting. Thank you. I'll let others before I chime in again.
May I ask a question?
Yes, please.
Yes. Hi, Dr. Robin Lougee. This was very fascinating to see application of things that we all use to be applied in such an interesting thing. Actually, while listening to you, I had a thought, and I just wanted to know if that is being addressed or talked about. So I was thinking about, using it in some sort of like making food security, sustainability, also bring in that piece. And I thought about this, push for Impossible Burger to make it taste exactly like meat so that people can shift from all the negatives of the meat industry. So is there anything that your work or flavor has a direct impact in that kind of topic?
That's a fantastic question. So the alternate protein market is, if you follow the stock market, is like really hot these days. We're seeing great competition between companies. McDonald's, Burger King's now have these alternate proteins. And yes, one of the companies involved, Impossible, they actually filed for a patent for their AI system called Giuseppe. And if you're on a computer, I would encourage you to just Google it, because they named it for an artist who used food to make portraits of humans. And it's really fun. But yes, they claim that their success is due to AI. So I think that's really exciting. I don't know the details of their system. Again, it's patented. Everything is so hush hush. But I think that's going to be a big part going forward, because there's, those companies struggle. And it's not just with flavor. So I focused on flavor. In the impossible or alternate protein markets, one of their challenges is also texture, right? How do we get the texture? And I find this area so fascinating, because we all know food, but the science of taste and perception is the least studied sensory. And we actually taste with our eyes. There's studies where they put two glasses of wine and ask people to say, did they taste different? Little did they know, one was red wine and one was a white wine with red food coloring in it, right? So they were different. And if they had seen that, they would have described it differently, but they didn't. They evaluated it as a red wine. So, we taste the crunch, right? The chew. And I didn't mention it in my talk, but also just for your own knowledge, these product developers aren't thinking about taste as a point in time. They think about your flavor experience over time. So have you ever had the condition where you're eating potato chips and you're like, I just have to have another one? You can't stop, can't have just one. Well, that has to do with the flavor at the end of the flavor experience, right? So they actually designing, and I don't want to go dark, but you could imagine designing products to be addictive. What contributes to that? If you have a very fine garlic, I mentioned that it coats your tongue. So fine garlic would give you an experience of garlic in the beginning of that journey, but it quickly wears off. So you would add different garlics of different sizes, of different composition to maintain a garlic presence. So it's so cool. You perceive your flavors depending on who you're eating with, right? So if you do a sensory food taste, you have to actually go into a room where you're devoid, your sensory deprivation, except for what they're serving you. So I just think that this kind of interdisciplinary science really needs mathematicians, engineers, and computer scientists, because of, for instance, we're basing it on optimal transport problems, right? Wasserstein metrics. It's would be unusual for a food scientist to have the depth of mathematics to be able to think about how to digitalize this space. And so what you guys are learning and doing is so important. And I love the integrative discipline approach that you have.
Actually, I have a comment. We have a family friend whose son started working for Impossible Foods. Previously, he had worked for Joule. Okay, let's not touch that one. He has a PhD in chemistry from Berkeley. And he says their major product right now is synthesizing pork because of the Chinese market. Okay, which I find fascinating. So thank you.
Sure. And I think we've been so successful in AI with visual, right? Computer vision, OCR, right, is used, optical character recognition is used by the mail system. You know, we can do voice to text, you know, or voice recognition with our Alexas. So I think this is a frontier, you know, for us.
Any other questions?
Comments?
Comments?
Yeah.
I have a quick question, if I may. And I just wanted to say, first of all, thank you. This is a very, very intriguing and just an amazing presentation. So thank you for presenting. So my interest is in the wine consumer, wine purchase decision process. And actually studied hospitality here at Eisenberg and used to work as a sommelier in restaurants. And so I wanted to ask you specifically about kind of how the flavor mapping works. For instance, like when you're making lemonade, it takes a lot of sugar before the juice stops tasting sour. And so when you look at the flavor mapping and on the map it says sweet, would that be because there's the grams per liter of sugar, say, in a liquid, but then also the perceived sweetness based on the balance of the chemistry there? So could you maybe just speak about that a little bit?
Yeah, I mean, you know, we had just mentioned that this is the least studied area, you know, so flavor, so perception of sweetness, for example, you know, it's highly nonlinear, right? I could put a little bit of sugar in a glass of water, you wouldn't taste it. You know, I keep adding it, and at some point, your flavor receptors on would be able to perceive it, and then you would taste sweeter and sweeter and sweeter, and it get to a point where you couldn't tell if I added any more, right? It'd be non-saturated. So it's like a step function with some kind of unknown linear curve. And I wish we could, you know, figure all that out. The diagram that you were referencing is more of conceptual of how the product developers would like us to be able to map the space. But the problem is it's just not that clean. And that's neat. It's more of a cartoon version. And you can think about this like, how would you draw a circle around like cheddar jalapeno, or, you know, like the flavors combine and intersect, and it's highly multidimensional. So the way you could say that, you know, the way we approached it was based on the data we had. And the data we had was ingredients. So, you know, what's the, you know, the chemical names, or, you know, the garlic SKU number and their amounts. So you could think of it like as a probability distribution. And we had lots of other data, but that's sort of the key one. And so we tried to infer a distance between those. And so the idea of the taste perception having minimum and maximum amounts in this version of the system, it's not there yet, right? And there are a lot of people working, as I'm sure you know, a lot of people working on different problems in the wine industry, both from the consumer end and the product blending end. Like, how does Gallo wine get the same consistency every year, despite the fact that all their grapes are changing year to year in buying? So I think that is one of the areas where I've seen the most work in the literature is in the wine, but we haven't gotten down to the level I think you're asking about yet. And there is a paper, I don't know if I mentioned it, we did write a paper for a food sciences journal. If anybody's interested, I can send the link, but it's not it's about at the same depth as this presentation. There's also a YouTube video. If you search McCormick, IBM, AI, McCormick published a video. And in the background of the video, you can see some of the pictures that we use, because the human developers, they wanted to see the choices of the ingredients visualized. And so we're taking, a recipe may only have, 5, 10, 20 ingredients out of a space of like a huge number, right? So we had to figure out how to try to visualize these, solve nearest neighbor problems, and do a lot of other, and you can see some of the bouncing visuals that we created for them. We were fortunate in that we had a user design experience person, that was their area of research, working with us. So I'm sorry, but I'm sorry I can't say more, Matthew.
That was a great answer. Thank you. I really appreciate that.
I do have a question, and this is more related to the ethical concerns or regulation using AI in consumer products. Do you foresee, or in the course of the research, has there been like any resistance to such projects?
Well, it's funny. I was, being, I guess I'm labeled an AI researcher now, but, I was so excited about the application and being able to help product developers deal with this enormity of the space they have to search and be faster, be better, be novel. I was really excited. So when we started the publication process of announcing our work, and we made the little, the beautiful video that McCormick posted, I very excitedly read the comments from people. And much to my surprise and shock, not everybody shared my enthusiasm. They were like, get that AI robot out of my kitchen. I don't want AI messing with my food. So I think that's why, unlike Botacario, McCormick does not advertise on their packages, right, that it's there. So I think there's a lot of sentiment, Vivian, to your point. I think a lot of people feel that way. But in some ways, I like that the AI can help with unconscious bias that the human product developers have. So if you're bidding, if you have a client who wants a flavor product and you're bidding on that against other flavor houses, if you're able to have a submission before the others, it's a competitive advantage, but only if it's pretty good. So the product developers working in the flavor solution space have time pressure. And as a result, they have sort of their go-tos for certain formulas. And so they don't really have a chance to explore and take advantage of what someone in New Delhi has developed, or someone in Asia. Like, it's a global lab and everyone's in their own silos, right, in their own companies. And so the AI system also helps them share information that they wouldn't otherwise, and can help break down some of those go-tos, because they're not just suggesting something new, but they're increasing the speed at which they can try. So hopefully, it's, with everything, there's pros and cons, but I hope that overall it's a net plus. Did I answer your question?
Yes, you did. Thank you. If there are no more questions, I would like to ask everyone left to kindly turn on their videos so we can take a print screen for informs and for our records. I could do one more and then just smile, say cheese. Awesome. Okay, thank you so much, Dr. Robin. We've included in the chat the networking session. So we encourage everyone to kindly attend. And that's it. Thank you.
All right. Have a great vacation, you guys. Thank you for the invite.
Enjoy your Thanksgiving and bye.